Hi, boys and girls. It's time for our lesson, chapter 12.4, and this is kind of a fun lesson because we have lines that will cross over each other, and we call those intersecting lines, but sometimes they form a right angle, and sometimes they don't, and sometimes they're parallel, and sometimes they're perpendicular, and those are some big words that we're going to be learning about today. So open your book to page 715. Our essential question is, how can you describe line segments that are sides of polygons? Well, look at this polygon. How many pairs of sides are there? Well, how do you know the shape is a polygon? First of all, we know it's a plane shape made up of line segments, and it's closed. So it's closed. Line segments. Closed line segments, and there's nothing curved. Okay. Now, these could extend and keep going is what they're saying. So these two lines form sort of like this. They intersect. Lines that cross or meet are intersecting lines. Intersecting lines form angles. Do you see there's an angle here? But there's also an angle here, and one here, and one here. The orange and blue line segments meet and form an angle. So they are, they're talking about these, they are intersecting lines. I'm just going to abbreviate INT for intersecting. You see, I mentioned that we could continue these. If these were truly lines, they would continue on past the figure. Okay? So look at the next one. Intersecting lines that cross or meet to form right angles are called perpendicular lines. And I see right here and right here, I have perpendicular lines. The red and blue. The red and the blue segments meet to form a right angle. So they are perpendicular. Perpendicular. That's a big word. Perpendicular. Lines that never cross or meet, and they are always the same distance apart, are called parallel lines. Now, if we were in school, we'd be looking around the room and we'd be finding all sorts of parallel lines, like in the ceiling tiles and in the bricks. These are lines that stay the same distance from each other and go on forever and never cross. So the polygon above, that's this, has how many parallel lines? Well, let's see. If this line continues and this line continues, eventually they're going to cross. They cannot be parallel. How about if this line continues and this line continues? The blue and the green lines. Those are parallel. And there's only one pair. There's two lines, but two lines together make a pair of lines. One pair of lines. Okay, let's take a look at the next page. 716. It says, try this. Draw a polygon with only one pair of parallel sides. Then draw a polygon with two pairs of parallel sides. Okay, outline each pair of parallel sides with a different color. Well, I'm going to draw a polygon with only one pair of parallel sides. So first I'm going to start with my parallel sides. well, I want to be on the lines, but I need to calibrate again. 1, 2, if I bring this down like this, I have only one pair of parallel lines right here. Now, if I have 2, I could draw a square or a rectangle. This is parallel with this. This is parallel with this. So that would be 2 pairs of parallel lines. Okay? Which sides appear to be parallel? C and A are parallel. How about B and D? Are they parallel to each other? Could they keep going forever and ever and never meet? B and D are parallel to each other. So we have 2 pairs of parallel lines. Look at the green sides of the polygon. Tell if they appear to be intersecting or perpendicular or parallel. Write all the words that describe the sides. So I could continue these lines and keep going. And are they going to ever cross? I didn't do a very good job with this. They're never going to cross. They're going to keep going forever and ever at the same distance. They are parallel. Come back. So we're going to say they are parallel. Now look at these 2 green lines. If we keep extending them, do they cross? They do. They are intersecting. Now let's try these green lines, this one and this one. Do they intersect? Yes. Now, write all the words that describe the sides. Where they intersect, do we get a right angle? We do. So they are perpendicular. Perpendicular. Okay. Look at the green sides of the polygon. Tell if they appear to be intersecting, perpendicular, or parallel. Do the same thing with these. I'm going to go ahead and get started on the assignment, which is on page 719. Okay, it says, look at the dashed sides of the polygon. This is the one with the little spaces. Those are the dashed lines. Tell if they appear to be intersecting, perpendicular, or parallel. So this line with this line. Oh, they're parallel. How about this line with this line? Are they intersecting? Are they perpendicular? Are they parallel? Write whichever words describe these 2 lines. There's 2 for this one. How about this? How about these 2 lines? What about these 2 lines? What about these 2 lines? Okay. Here are your word choices: intersecting, perpendicular, or parallel. Two of these problems up here have 2 answers, meaning intersecting and perpendicular. 2 of the shapes are. Number 7, which shapes appear to have parallel sides? There are 3 of them. Write the letters of 3 of them that have parallel sides. Which shapes appear to have perpendicular sides? That means they form right angles. There are 2 of them. Now, you can go ahead and write something here. Give some examples of perpendicular lines inside or outside your classroom. So it could be at your home. It's outside the classroom. So I might say the window frame. Okay, let's go on to the next page. 720. How many pairs of parallel sides does this quadrilateral appear to have? Which sides appear to be parallel? Is A parallel to B? Is A parallel to C? Is B parallel to A? Is B parallel to D? Mr. Lance designed a class banner shaped like the polygon shown. What is the name of the polygon? Remember, it's named for the number of sides and angles it has. So count the number of sides. If you need to, go back to page 710. How many angles greater than a right angle does this shape have? You could use your straw or the corner of a piece of paper. We want to see how many have angles greater than right. How many line segments does this shape have? Count them carefully. Don't go too fast. What fraction names the shaded part? So we have the total number and then the shaded part. The shaded part is our numerator. The total number of shapes is our denominator. Take a picture and send it to me when you're finished.